Assalamualaikum and hi, we continue back on frequency response design via Compensator part 3. So the last one we stopped at step 3. Now for step number 4, the first one we need to determine damping ratio zeta from the given percent of overshoot. So using this formula. And the next one, determine the desired phase margin dPm, okay, which is equal to required phase margin using the value of damping ratio using this formula. So step 4A and 4B is based on these two formulas. Okay. The next one, from board plot in step 3C, determine the phase margin. Okay, we're back to step number 3. From magnitude plot at 0 dB, you determine the omega gain crossover frequency, and then at the same frequency, refer to phase plot. So at omega GCO, read the value of phi m, which is equal to the value of degree from phase plot. Okay, at omega GCO, refer to phase plot. So you read this value of phi m, and then determine the uncompensated phase margin using this formula. The next one is determine the phase angle to be added based on correction factor. The correction factor usually is between 5 to 12 degree. So based on the correction factor given in the question, use the correction factor, the uncompensated phase margin from step C, and the desired phase margin from step 2 to determine phi max. Okay, for this one. For step number 5, determine the attenuation factor beta, which is equal to this formula where the beta value is between 0 and 1, larger than 0, lesser than 1. So this is the attenuation factor beta. For step number 6, okay, we need to determine the uncompensated magnitude based on the beta value using this formula. So this is the uncompensated magnitude in dB. Using this value of magnitude in dB, we refer to magnitude plot and find the frequency at this value, the uncompensated magnitude. So at uncompensated magnitude in dB, we determine the frequency, which is this is omega max, the maximum frequency for uncompensated magnitude. So refer to the magnitude plot. Okay, that's it for step 6. We continue step 7 until step 9 in the next video. Thank you.